In this lesson, we're going to be focusing on trigonometric identities, and we want to be able to apply the trig identities to simplify and or evaluate trigonometric expressions. And here is our focus standard. So we're going to prove some basic trig identities and apply them, and then later on we'll do some of this. Okay, so what are trig identities? So first, think of it like an algebraic equation. That's kind of like what they look like. So a trig identity is an equation, so it has to have an equal sign. It involves trig functions, and it has to be true for all the values which every expression in the equation is defined. They help us evaluate functions, simplify expressions, verify identities, which we'll spend quite a bit of time on, and solve equations. Okay, so some basic identities which you're probably already familiar with. So on the unit circle, we had order pairs, and we said, okay, well, tangent is the ratio of y over x. And we said, well, y is sine and x is cosine. So tangent function can be thought of as the ratio of sine over cosine as long as the cosine is not equal to 0. Therefore, it would be undefined. Okay, so the cotangent is the reciprocal of tangent, and so that means that cotangent is the ratio of cosine over sine. So basically, any place you see cotangent, you can write it like this. And of course, as long as sine is not equal to 0. Okay, then we have our reciprocal identities, which I believe we're very familiar with. Sine is the reciprocal of cosecant. Okay, and remember the catch is that whatever is in the denominator can't be equal to 0. So cosecant can't be equal to 0. Sine can't be equal to 0. Okay, cosine is the reciprocal of secant, and secant is the reciprocal of cosine. Tangent is the reciprocal of cotangent, and cotangent is the reciprocal of tangent. And again, and this is for all of the denominators cannot be equal to 0. Okay, so let's go ahead and apply some of these basic trig identities. So let's go ahead and we're going to do over here, it says, okay, so we know that the secant is the opposite of the square root of 30 over 3. And we want to find the cosine. So we know that cosine is the reciprocal of secant. And so that's the identity I'm going to use. So if I want to find the cosine, I am going to substitute the opposite of, I'm going to substitute the opposite of the square root of 30 over 3 for secant because they're equal to each other. And now I'm just going to simplify. So remember that when I divide, it's the same as multiplying by the reciprocal. So I have 1 times the opposite of 3 over square root of 30. And then, of course, 1 times anything is just itself. And now I just have to go ahead and rationalize my denominator. So I get negative 3 square root of 30 over 30. Okay, so we don't have an identity that relates cosecant to cotangent, but I know that cosecant is 1, and we're using beta because it's just another Greek letter that we can use to represent an angle, is 1 over the sine. And I know that cotangent of an angle is the cosine over the sine. Okay, and I want to figure out what the secant is. And I know that secant is going to be 1 over the cosine. Okay, so now let's go ahead and we're going to substitute some stuff into this. Okay, so I know that the cotangent is negative 2 square root of 10 over 3 for this angle beta. And I know that since the cosecant is negative 7 over 3, 7 over 3, that if I just go ahead and I reciprocate it, I'll get the sine. So I know that I have cosine of theta over the sine of beta, and the sine of beta has to be the reciprocal of 7 over 3, which is 3 over 7. So now I'm going to simplify this equation. I'm going to solve for cosine. So I know that dividing is the same as multiplying by the reciprocal. So I'm just going to multiply, actually I'm going to just do this. I'm going to multiply this side by 3/7 to make that cancel. So I'm going to multiply this side by 3 over 7. So those cancel out, which gives me cosine. I put theta, and that is my bad. I meant beta. I meant beta. Okay, so we have cosine of beta. This 3 cancels that 3. So we're left with, excuse me, negative 2 square root of 10 all over 7 by just multiplying fraction stuff that I learned in middle school. Okay, so now we're going to go ahead and we're going to look at Pythagorean identities. And yes, you're right, Pythagorean identities are based on the Pythagorean theorem. Remember, the formula for Pythagorean theorem is that a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is its hypotenuse. So thinking back to our unit circle, for any point on the unit circle xy, then this leg has a value of x, this leg has a value of y, this is my right angle, this is my angle in the normal location, or this would be our origin, and the hypotenuse is equal to 1. So using that, we get x squared plus y squared equals 1. Okay, well, we know from using the unit circle that y is sine. So we know for our unit circle that y is the sine of the angle. So every place there's a y, I can substitute sine of theta. And cosine is the x value. So every place that there is an x in this equation, I can substitute cosine squared. So what do we have? We have that the square of the cosine plus the square of the sine is equal to 1. And we also know that because addition is commutative, I can write it a different way. But most important, we're going to talk about when we're squaring a trig function, we write the square right next to the trig function, and then we write what we're taking the sine or the cosine of. And here is our first trig Pythagorean identity. Now there are 3 of them, and all 3 of them are variations of this one. Well, this one plus 2 other variations, I should say. Okay, so first one is one we just went over. And remember, because addition is commutative, it can be written cosine squared plus sine squared. Okay, so kind of some things to remember. Sine goes with cosine in the trig identities. Tangent goes with secant, and then this one's my coco. Cotangent, cosecant. So tangent squared plus 1, cotangent squared plus 1 gives us secant squared with theta, cosine squared theta. Okay, so now let's go ahead and use them. So it says find the cosine and tangent if the sine is negative 1/3. Remember what this means is that the cotangent is going to be evaluated to be a negative. And so cotangent is going to be negative in quadrants 2 and 4. Now, since sine is negative also, sine is not negative in quadrant 2, which means we're looking at a quadrant 4 angle. And quadrant 4, remember, that's where cosine is positive. So we know that when we evaluate the cosine, we're going to get a positive number, and when we get the tangent, it's going to be a negative. Okay, so What do I know? I know that sine squared plus cosine squared is 1. And I know that the sine is negative 1/3. So since this is the sine of the angle, if I square it and I add the square of the cosine, I'm going to get 1. So negative 1/3 squared gives me 1/9. I'm going to subtract 1/9 from both sides. And where 1 is the same as 9/9. So if I subtract 1/9 from 9/9, I get the cosine squared is 8/9. And what's left to do is take the square root of both sides. Don't forget your plus or minus. So I get the cosine of theta is plus or minus the square root of 8. And don't forget square root of 8 is 2 square root of 2 over the square root of 9, which is 3. Now, I know that this angle has to be in quadrant 4, and cosine is positive, which means I don't actually need the plus or minus because I know it has to be a quadrant 4 angle, so I just want the positive value of it. So we have cosine is 2 square root of 2 over 3. Okay, so what else do I know? I now need to go ahead and find the tangent of this angle, but I know that tangent is simply the sine over the cosine. So now I can go ahead and figure it out from here. So I know the sine is negative 1/3, and I'm going to divide by the cosine, 2 square root of 2 over 3. So now I'm just going to go ahead and work this one out. Negative 1/3 times the reciprocal, 3 over 2 square root of 2. 3's cancel. It comes out to be negative like it should. And I have negative 1 over 2 square root of 2. And to make this more perfect, I just go ahead and rationalize and multiply numerator and denominator by square root of 2. So that's going to give me that the tangent is negative square root of 2 over 4. So tangent is negative square root of 2 over 4. Okay, let's do one more. Seems like these take a lot of room, huh? Okay, so it says find the tangent and the sine if the secant is 6 over 5. So what do I know? I know that tangent and secant go together. And there's a trig identity, Pythagorean identity that says the square of the tangent plus 1 is equal to the square of the secant. So by substituting in here for secant, 6 over 5 squared, I get the square of the tangent plus 1 is this. This gives me 36 over 25. And I'm going to subtract 1 from both sides. Remember, 25 over 25, excuse me. $25 over 25 is the same as 1. So if I go 36 over 25 minus 1, I get that the square of the tangent is 11 over 25. And the last thing, of course, remember, square root. Both sides, plus or minus, and I get that the tangent is the square root of 11 over 5. Okay, now, do I need the plus or the minus? So is it supposed to be positive value or is it a negative value? Well, to figure that out, I look back at what we know. We know that sine is positive in quadrants 1 and 2, and that the secant is also positive. So the only place sine and secant are both positive is in quadrant 1, which means I only want the positive root of the tangent. So this would be 11, square root of 11 over 5. So we know that tangent is sine over cosine. Which tells us that we have, so far, square root of 11 over 5 is equal to sine over the cosine. The secant tells us the cosine because secant is the reciprocal. So the cosine of the angle x has to be equal to 5 over 6. But we don't know what the sine is right now. Okay, so I'm going to multiply both sides by 5 over 6. So 5's cancel, leaving me square root of 11 over 6. And on this side, 5, 6 cancels 5, 6, leaving me sine of, I should put an x there, sorry about that. So we have sine of x is square root of 11 over 6. Tangent of x is square root of 11 over 5. Okay, so cofunction identities. So remember that what we figured out, like things like the sine function. If I just go ahead and I shift it and reflect it, I actually get the cosine function. That's what all of these are based on. Okay, so if I have the sine and I want to make it into a cosine, it's cosine of pi over 2, which is the phase shift, minus theta. And what that does is, that's like our x, theta is like our x. And if I factored out a -1, it's a phase shift of right pi over 2 and a reflection over the x-axis. So cosine is pi over 2 minus theta equals sine of pi minus 2 over theta. Tangent goes with cotangent. And cotangent goes with tangent. And cosecant goes with secant. And then remember, cosecant is the one that looks like this, and secant looks kind of the same. Okay, so some other identities we need to make sure we know is even and odd identities. So remember, an even function is defined as if you evaluate the opposite of x into a function and you end up with the exact same value for y as when you put the opposite or positive value of x, then it's an even function. And that's because it has vertical symmetry at at x equals 0. Okay, an odd function says if you do the same thing, evaluate the opposite of x, and you come out with the completely opposite value of y, then it's an odd function or has origin symmetry. Okay, so out of these 6 basic trig functions, only 2 of them are even, and that's cosine and secant. So what that means, if I evaluate the cosine of a negative angle, it's exactly the same as the cosine of a positive angle. It's opposite. Same thing for secant. If I evaluate the secant of a negative angle, I'm going to get the secant of its opposite. Okay, sine, cosecant, tangent, and cotangent are all odd. And so if I go ahead and I take the sine of the opposite, I get the opposite of the sine. So basically it's like saying that if I did sine of negative 90 degrees, it's going to be the same as the opposite of the sine of 90 degrees. Negative 90 degrees is at 3 pi over 2, which is -1. And so sine of 90 is +1, but the opposite of 1 is -1. So that's kind of how it works. Okay, so cosecant, we would say, is the opposite So cosecant of a negative angle is the opposite of the cosecant of its positive angle. Tangent, same thing. And cotangent, same thing. Okay, so let's go ahead and look at these and how we can use them. So what we have is we want to use those sets of identities to figure out these. Okay, so it says that the sine of the angle is this. Okay, so we know that the sine of the opposite of theta is equal to negative 0.97, and it's also equal to, because of our identity for even and odd, it says that it also has to be equal to the opposite of sine of theta. Okay, so what we know is the opposite of the sine of the angle is equal to negative 0.97. Okay, so cofunction identities is what I see over here because I see that pi over 2 minus theta. So I know that from those cofunction identities that the sine of the angle is equal to the cosine of pi over 2 minus theta. Now, I know what the opposite of the sine is, so that means the sine of this angle has to be 97 hundredths. So if I substitute 0.97 for sine of theta, which I can do because they're equal, I get that the cosine of pi over 2 minus theta is 0.97. Okay, let's try it again. Let's go ahead and use this one down here. Okay, so this is what they started us with, and we want to find the cosecant of the opposite of beta. Well, I know that cosecant is an even function, so I know that the cosecant of an angle, the opposite of an angle is the same as the cosecant of that angle. Opposite. Okay, and I also know from my cofunction identities that the cosecant of an angle is equal to the secant of pi over 2 minus beta. Okay, now notice this is different. Why? Well, remember that thing we did where we could factor out a negative 1? So if I factor out a negative 1 from pi over 2 minus beta, I end up with a negative in front of the pi over 2 and a positive in front of the beta. And using the commutative property for addition, I end up with this. Okay, so now secant we know is odd. So what we have now is we have this right here is the same as the secant of the opposite of beta minus pi over 2. And because secant is an even function, I know that the secant of the opposite of the angle is the same as the secant of beta minus pi over 2. And I know that that has to be equal to the cosecant of beta. Okay? Now I'm trying to find the cosecant of the opposite of beta. And I know that because of my even odd functions, the cosecant of beta is the same as the cosecant of the opposite of beta. So the cosecant of the opposite of beta is equal to the secant of beta minus pi over 2.